Okay.
Just a minute, please. Just a minute. اقدر اطلع انيميشن كامله بابا؟ يعني هذه فروم بيكنيك ها؟
Just a minute, please. Just a minute.
Yes, sir. Yes, sir. Yes.
The biomaterial which are used for structural application in the field of medicine are known as biomaterial. What's the biomaterial? This material which are used for structural application in field of medicine. The material used may be bioceramic, biometallic materials, biopolymer materials, biocomposite materials.
Structural application in the field of medicine are known as biomaterial. What's the biomaterial? This material which are used for structural application in field of medicine. The material used may be bioceramic, biometallic materials, biopolymer materials, biocomposite materials. Structural application in the field of medicine are known as biomaterial. But the biomaterial, this material which are used for structural.
Please, the sound is very good or not?
Yes, sir. Yes, sir. Sound is good, sir.
Okay, okay. This scientific biomaterials, biometallic materials, biopolymer materials, bioceramic materials, as well as semiconductor materials. Semiconductor materials can be used in medical application as biosensor and microelectrode. In ceramics, may be used in heart valve, in bone replacement, and dental implant. Polymer used to drug delivery device, skin, cartilage, and in implant. Metals, orthopedic, screw and fixation, as well as dental implant. This corrosion in biological environment. Corrosion in biological environment can be seen that anodic reaction and cathodic reaction in active metal and passive metal. The materials can be used in biological environment, in medical application, maybe cobalt chrome alloy, maybe titanium alloys, maybe stainless steel. Active passive behavior can be occur for these material, for these metallic materials, this anodic reaction and this cathodic reactions. In corrosion, by visual inspection, can be seen that uniform corrosion, pitting, Griffiths corrosion, galvanic corrosion. And by microscopic examination, can be seen that erosion, cavitation, fritting, intergranular. And the third by microscopic examination, exfoliation, de-alloying and stress corrosion, cracking and corrosion fatigue. But special inspection tools, erosion, cavitation, fritting, and intergranular. In corrosion,
Sir, can I interrupt you, sir?
Required to determine the corrosion rate equals delta W divided by area, time,
Professor, can we go for full screen
MBD or
mode?
MBY. Corrosion rate in MBY, where this MBY milli-inch equals 1 divided by 1,000 inch. This corrosion rate equals 1.44 divided by
Professor, please make it full screen. Please make it full screen.
Yes.
Control F5. Please make it full screen.
Yes, yes. The screenshot. Maybe this without image for you or without screenshot.
No, please make it full scan. Full scan.
That's sir, slide mode, presentation mode, sir.
Yes, yes.
F5.
Okay, okay, yes.
Control F5.
Where they take nano-sized particles and make composite materials which have got very, very fine.
This, sir, slideshow is
Yes,
visual,
yes,
not
yes.
slideshow. In
Okay.
slideshow, you just go
Okay,
complete.
okay.
But it is said that it should be at least 200 nanometers, but sometimes say, okay, even up to 500 nanometers, particles are there. We call it as nano.
The screenshot present for you at this time?
Yeah, sir. This is visible, sir. Can we go for slideshow? This Control F5.
Okay, again, not one nanometer, but just that up to 500.
This, sir, below one in PowerPoint, below one window is showing that is a slideshow.
Okay, but I hope the screenshot present for you.
Okay, sir. Okay, sir. Go ahead, sir.
Yes. The corrosion rate can be equals 1.44 divided by density times corrosion rate in MDD. 9 slide, corrosion rate in MBY equals 0.1288 times I-core equivalent weight divided by density, where MBY is milli-inch per year and I-core is the corrosion current density, microampere per square centimeter. The equivalent weight of the corroding for materials and the density of the corroding and the density for corroding materials equals gram per cubic centimeter. This arrangement of electrode in the corrosion test, working electrode and reference electrode and auxiliary electrode. This standard electrochemical cell, this figure representation of the plot of potential Vs current density responding log in the vertical line potential millivolt and the vertical line I-core microampere per current density microampere per square centimeter. The hypothetical TOEFL plot, this a hypothetical TOEFL plot, anodic polarization and cathodic polarization, and beta anodic, beta cathodic, this slope for anodic reactions and this slope for cathodic reactions can be determined I-core and can be determined E-core. Where the concept of corrosion, where the friction and wear behavior of materials depend on many parameters and conditions, including material binding, contact geometry, applied normal load, and roughness, environment, temperature, chemical interaction, and sliding configuration. Many mechanical assemblies must work in multiple sliding and environmental conditions. In applications, maybe in automobiles, in watercraft, in other spacecraft and wind, water, and solar energy conversion device, engine. The applications can be suffer for wear in mechanical tribology. The tribology contained three terms: wear, friction, and lubrications. This tribology experiment, surface roughness is very effect on tribology, contamination, debris generation, and machines chemistry. This roughness contact elastic and plastic deformations between two surfaces. Can be seen that this material interface and environmental contribution to friction and wear. This environmental sensitivity and chemical degradation of wear-resistant polytetrafluoroethylene. This polymer composite on metal counter sample. Surface chemistry, polymer tribofilm, contact pressure, and the braze can be occur for this friction between polymer composite and metal counter sample. Sliding block subjected to normal and tangential force. This force normal to be horizontal plane and tangential force acting parallel to the horizontal plane. These mechanisms of sliding block can be classified where in more types. Wear is very complex phenomena and usually involve progress flows of materials. Maybe abrasive wear. Abrasive wear is produced by a hard, sharp particles embossed on and moving on softer surface. Hard surface with soft surface can be led to abrasive wear. Hard surface with soft surface. Adhesion wear. This localized bonding between contact solid leading to material transfer or loss from either contacting surface. In corrosion wear can be occur when sliding surface is corrosive environment. This wear action takes place in two stages. First, there are corrosive attack on the surface. Then the sliding action wears off the corroded surface film. Another types of wear. Surface fatigue. This contact between asperities with the very high local stress that are repeated large number of times during sliding or rolling led to fatigue. Why? Because this repeated large number of times during sliding or rolling with or without lubrications. High plastic deformation cause crack initiation, crack growth, and fracture. Another type of wear, erosion wear. This erosion wear, the erosion is referred to the continuous loss of solid surface due to mechanical interaction between the surface and the fluid, which may be a multi-phase fluid or impinging solid or liquid particles can be impinged for the surface, for the material surface, led to erosion wear. This abrasive wear occur between hard surface and soft surface. Adhesive wear. This adhesive wear. This mechanisms for adhesive wear between two surfaces in interface, both can be occur in pitch line and pitch arc, scuffing, and adhesive wear in gearbox. Influence factor, similarity of matting surface, and additives for lubrications, film thickness, load, viscosity, speed. Gear tooth size in gearbox is very important in adhesive wear. This abrasive wear, two-body abrasive wear and three-body abrasive wear. This been on disc method to determine the wear rate. Fixed ball, wear track, rotating disc, and wear track and rotating discs in B and C block. Another design for bin on disc method. This corrosive wear may be uniform attack and intergranular attack. and pitting attack, subsurface attack. This corrosion rate typically drops for every 10 degrees Celsius increase in temperature. The techniques to reduce corrosion with wear, corrosion-resistant metallurgy, and the fluid contamination can be controlled. Control moisture, water, acids, bacteria, as well as protective barrier coating must be used. Surface treatment must be applied. Corrosion controlling additives, rust inhibitors, metal dictators, and inhibitors for controlling the corrosion. This erosion wear, when erosion wear mechanism, loss of material as a result of repeated impact to small solid particles. Factors can be effect in erosion wear, maybe particle shape, particle size, particle hardness, particle velocity, and temperature can be effect in erosion wear. Methodology to testing in wear. In erosion wear device to determine the mechanical degradation of a surface resulting from solid particles impingement causing local damage, combined with the material removal. The determined amount of material volume loss is normalized by the abrasive flow rate. It's very important, the flow rate for erosion wear. To provide the erosion value, which is defined as wear volume per gram of abrasive wear. The surface fatigue, when repeated loading at the surface. Surface fatigue often begins by hard or soft particles can be led to surface fatigue. Can be controlling surface fatigue by increase film thickness and reduce surface roughness. Reduce surface roughness is very important for surface fatigue. Maximize hardness and lower traction coefficient. High pressure viscosity coefficient. Avoid particle contaminations. Keep oil dry. This controlling to surface fatigue. Increase film thickness is very important. And reduce surface roughness is very important. In fatigue applications, require increase the residual stress, especially increase compressive residual stresses for increase the fatigue resistance of materials. Short pinning is very important to improvement the surface for fatigue applications. Short pinning, increase hardness and increase compressive residual stresses. These equations for determine the total volume of wear debris produced equals K dimensional constant W total normal load times L sliding distance divided by hardness of the softest contacting surface. Is very important, this equation, to determine the total volume of wear debris in wear applications. Wear dependence. Effect in wear, normal load, very important parameters, relative sliding speed,
beyond 2%, below 2%,
relative sliding speed,
maximum कितना होगा? Maximum theoretically.
Okay.
Theoretically maximum.
There is a there is
No, not.
The lecture is very clear or not, please?
Yes, sir. Yes, sir. Yes, sir.
I
Participants, kindly mute yourself.
I need to complete what the More sound in my lecture. Why?
Participants, please kindly mute yourself. Let the professor continue. Thank you,
Yes.
sir. Thank you. Please.
Thank
Please,
you
sir.
so much. The parameters can be effect on surface sliding in wear, normal load, relative sliding speed. The initial temperature is very important. Thermal properties, mechanical properties, chemical properties of the material in contact is very important also. Thermal properties, mechanical properties, chemical properties of the material in contact is very important for surface sliding. This experimental setup for bin on disk can be seen that this bin on disk schematic diagram of loading configuration of bin on disk method. This bin and disk were fitted where track diameter was measured, load applied in the dead cell, values of displacement, time, speed, load, and diameter of disk were entered for determining the wear rate. For determination of wear rate, displacement value of every second and coefficient of friction were noted, where values were calculated from displacement value. This table explains the specific wear data obtained using bin on disk system with a load of 0.4 kilogram force and the speed of 1.8 meter per second. Wearing surface mild steel and 60-40 brass and polytetrafluoroethylene and etc. for another material with counter surface. Maybe the wearing surface mild steel, counter surface mild steel. But another example, 60-40 brass as wearing surface, but the counter surface tool steel. W equals wear rate, cubic millimeter divided by meter, and hardness, kilograms divided by square millimeters. Can be used hardness figures micro hardness for determining the hardness, and coefficient of fractions can be determined by this test, as well as K, the constant of wear, Urquhart constant. The wear rate for titanium 6 aluminum for vanadium. These materials can be used as biomaterials under ambient condition at 1 kilogram, 4 kilogram, 8 kilogram, sliding speed vs wear rate. But B wear rate under vacuum conditions at 1 kilogram, 4 kilogram, and 8 kilograms. The biomaterials subjected to wear and determine the wear rate in ambient environment and under vacuum environment. What the tribocorrosion? Tribology consists of wear, friction, and lubrications. Tribocorrosion, corrosion plus tribology. This tribocorrosion system in industrial application, in engineering application, as well as in biomedical applications. The parameters can be effect in tribocorrosion system. Mechanical operational parameters. Normal force, sliding velocity and types of motion, shape and size of contacting bodies, alignment and vibration. These parameters can be effect in tribocorrosion system. Solution, viscosity of solution, conductivity of solution, pH of solution, temperature of solution, dissolved oxygen in solution can be effect in tribocorrosion mechanisms. Electrochemical, applied potential, ohmic resistance, repacification kinetics. In a tribocorrosion system, passivation and depacivations when contact the surface with loading led to passivation, but the loading can be led to depassivation and break the passive film at the surface. Film growth and active dissolution. Because depassivations may be stainless steel 316L subjected to aggressive environment. The body fluid is aggressive environment. Led to remove of passive film CR203 at the surface. Led to depassivation go to the fritting corrosion or tribocorrosion of 316L stainless steel and can be subjected to titanium 6 aluminum for vanadium or titanium 6 aluminum 7 niobium led to fritting corrosion. Materials which can be used in a tribocorrosion system, the parameters of materials, hardness, plasticity, microstructure, inclusions, surface roughness for materials, oxide film properties, water, wear debris, and material transfer is very important parameters effect on tribocorrosion mechanisms. Total material surface degradation process may be mechanical and chemical. Mechanical action, wear. Chemical action, corrosion. Tribology, friction plus wear plus lubrications. Corrosion environment. This is tribocorrosions. In research area, the tribocorrosion, mechanical action, wear, and chemical action corrosion led to tribocorrosion. Tribocorrosion of biomaterials. Maybe biometallic materials, biopolymer materials, bioceramic materials, biocomposite materials, and another classifications, nanomaterials, smart materials, okay, smart materials, high-tech materials can be subjected to tribocorrosion. Tribocorrosion of metallic implant. In some biomedical applications, implant material can be exposed to very complex surface conditions, including maybe static loading, dynamic loading, and relative motion with what? Maybe soft surface or hard surface in contact. Maybe soft surface and hard surface in contact. This together with the corrosives in corrosion can be occur in body fluid. Body fluid is aggressive environment, can lead to enhanced degradation process. Tribocorrosion is the degradation caused by combined effect, corrosion and wear. In implant material used to restore the function of part of the system in the body are typical example of application maybe where corrosion process can take place in biomedical materials, in bioimplant, in a human body. Biomaterial used for hip joint, maybe artificial implant, are subjected to static load of body weight and dynamic load due to activities such as walking, climbing, and relative motion between surfaces due to range motion of surface in a human body. The combined effect of wear and corrosion can take place in surface, but also other surface in contact due to variable loading and unloading, walking, climbing, another motion of human led to tribo corrosion. This equations for tribo corrosion is very important. This T represents the total tribo corrosion loss, and W is the wear loss in the absence of corrosion. W, the wear loss in the absence of corrosion. C, the corrosion loss in the absence of wear. And S represent the synergy between wear and corrosion.
നിന്നോട് എത്ര വട്ടം ഞാൻ ബാംഗ്ലൂർ മുതലേ പറയുന്നതല്ലേ?
Yeah, participants, please kindly mute yourself. Let the professor continue the lecture, please.
Yes, yes. Thank you so much.
Yes.
Thank you. The T equals W plus C plus S, where T represents the total tribo corrosion loss. W is the wear loss in the absence of corrosion. C is the corrosion loss in the absence of wear. But S is the represent the synergy between wear and corrosion at the same time. Corrosion and wear at the same time. Or the combination of the effect of corrosion wear and corrosion on wear and wear and corrosion. W plus C plus WC plus CW. This equation is very important. Can be seen that oral corrosion in dental materials. The dental materials, maybe hydroxyapatite materials, can be subject to oral corrosion. In dental materials, corrosion, morning saliva, and chewing gum saliva, where combination of corrosion and wear led to tribo corrosion of dental material. The simple example and easy example for tribo corrosion of biomaterials, especially in dental materials. In orthodontic wires can be subject to tribo corrosion, static loading and dynamic loading, as well as aggressive environment, aggressive fluid, saliva. This aggressive environment saliva with this orthodontic materials may be used smart materials, nickel titanium alloy, nitinol, and maybe in the 316L stainless steel can be used as orthodontic wires. In my papers, used duplex stainless steel. Duplex stainless steel consists of two phases, austenitic phase and ferritic phase, can be used as orthodontic wires. And I have patent and I have patent for using duplex stainless steel in orthodontic wires because the duplex stainless steel have high corrosion resistance and high wear resistance. Duplex stainless steel may be 2205, maybe 2507, maybe 2604. This term for 2205, 22 chromium, 055 nickel, 2507, 25 chromium, 7 nickel, 2604, 26 chromium, 4 nickel, and other research about 2101. My PhD student work for 2101 by improvement the surface by ion implantations and by plasma spray coating at the surface of duplex stainless steel by nitriding and by titanium nitride at the surface of duplex stainless steel 2101, 21 chromium, 1 nickel. Another examples for corrosion of dental implant, titanium implant, jawbone, natural tooth, and for this dental implant can be subjected to tribo corrosion. The mechanisms of tribo corrosion for titanium in saliva as dental implant, this saliva fluid, this food consists of acid and basic and salt, this microbes, this friction plus microbiological influence corrosion. The parameter is very effective in this case study. Time, pH, maybe degrees of pH, aggressive environment, change of oxygen, and in degrees of wear, surface roughness, and ions release. When more time for exposure for aggressive environment led to ions release in titanium 6 aluminum 4 vanadium. Vanadium is risk materials, can be replaced by titanium 6 aluminum 7 niobium, and can be used duplex stainless steel for when the nickel is low, the corrosion resistance is high. 2101 is high corrosion resistance than 2507, 2205. Okay. Another example for tribo corrosion, this dental implant subjected to axial load and oblique load. This metal ceramic micro movement, implant fixture, implants replaces tooth root. Axial load and oblique load. This static loading and dynamic loading, as well as aggressive environment, tribo corrosion of dental implant. Corroded titanium implant. Corroded titanium dental implant with pitting and oxidation. This dental implant subjected to tribocorrosion, bacterial biofilm, and or in applications in saliva. Saliva is aggressive environment. The dental implant subjected to tribocorrosion. The microstructure can be taken by optical microscopy or by scanning electron microscopy. Optical microscopy explain the microstructure, alpha beta phase for titanium, 6 aluminum for vanadium, 2 phase, alpha plus gamma phase, 2 phase in titanium, 6 aluminum for vanadium can be seen that the microstructure by optical microscopy. And the scanning electron microscopy can be explained the morphology and topography of corroded surface. Another test for investigation the corroded for implant by EDS, which concluded with scanning electron microscopy, energy dispersive spectrometry for investigate the chemical elemental change before and after fretting corrosion. Can be seen the titanium, aluminum, vanadium, or oxygen, or another element can be present due to saliva solution. This tribocorrosion for dental implant is very clear, can be present in dental implant required to replacement after more time. This tribocorrosion degradation can take place on different parts of medical device, such as hip implant, A, hip implant, and B, dental implants, and C, fracture fixation device. In bone fixation, tribocorrosion can be occur. In bone fixation can be occur tribocorrosion. This bone fixation in human body may be used 316L stainless steel, and in the research can be used duplex stainless steel 2205 as bone fixation materials. In this image, 316L, 18% of chromium, 8% of nickel, and less than 0.03% of carbon. 316L stainless steel can be used as bone fixation, subjected to tribocorrosion case. This tribocorrosion prone area is marked as dotted lines in artificial implant. This implant subjected to tribocorrosion due to static loading, dynamic loading, in a few points of wear mechanisms, and subjected to aggressive environment, fluid body. Another example, this tribocorrosion of artificial joints. Artificial joint subjected to tribocorrosion led to this aggressive corrosion. And in knee replacement subjected to tribocorrosion, maybe cobalt chrome alloy used as knee replacement. This fretting corrosion in metallic materials, this metallic oxide debris for titanium 6 aluminum 4 vanadium in contact with 316L. This titanium 6 aluminum 4 vanadium on contact with 316L stainless steel led to fretting corrosion. Tribocorrosion test principles. A tribocorrosion test can be achieved depending on the basic principles of electrochemical test using potentiostat. Potentiostat can be used in industrial applications for determine the corrosion rate in engineering applications. This technique requires 3 electrodes, counter electrode, reference electrode, and working electrode. The working electrode is mounted as O-ring with known surface area. And corrosion rate can be calculated by previous equations. Corrosion rate equals 0.1288, approximate to 0.13. 0.1288 I core times equivalent weight divided by density. Equivalent weight equals molecular weight or atomic weight divided by valence. In a tribocorrosion test is achieved by applying force on a pin or a ball in contact with the surface of specimen to create the wear. Okay? In a tribocorrosion test can be achieved this test by pin or ball in contact with the surface of sample to create the wear. At the same time with the corrosion device, potentiostat device. Then open circuit potential, linear polarization, anodic polarization, cathodic polarization, and cyclic polarization can be recorded. The wear rate of material calculated from the volume lost. Tribocorrosion test at controlled potentials. Cathodic and polarization conditions are grayed out after open circuit potential. Cathodic polarization and anodic polarization by Tafel method or Tafel plot by changing the applied potentials plus minus 200 millivolt around open circuit potentials to show the acceleration corrosion process. Maybe plus minus 200 millivolt around open circuit potentials. To show the acceleration corrosion process by wear, at the same time corrosion with wear. The evaluation of current was monitored before, during, and after the wear process. The wear rate K was evaluated using the formula equals V divided by F times S and equals A divided by F times N. This equation's 15. The schematic of the corrosion test can be seen that potentiostat, counter electrode, reference electrode, working electrode, and bin on disk. This strain gauge and displacement motor to determine wear rate in aggressive environment. In bio, tribocorrosion, the new term, tribocorrosion and biotribocorrosion. Tribocorrosion can be applied in biomaterials, can be called biotribocorrosion. The tribocorrosion test may be used in saliva solution, may be used in body fluid solution. Tribocorrosion test at anodic cathodic potentials. In order to further emphasize and demonstrate the contribution of corrosion in tribocorrosion, the tribocorrosion tests are performed at anodic potentials and cathodic potentials. Corrosion and wear to formation of larger wear track. The tribocorrosion tests were performed at cathodic potential except lower wear rate. Tribocorrosion studies voice clear, please. Professor Rao, is the voice is
Yes,
clear?
sir. Yes, sir.
Yes, okay. Thank you. The tribocorrosion study take a wide range of research due to wide applications. The tribocorrosion is surface degradation process resulting from tribological and electrochemical actions. Tribological actions and electrochemical actions. Maybe titanium 6 aluminum for vanadium, titanium 6 aluminum, titanium 6 aluminum 7 niobium, and duplex stainless steel, and stainless steel, and cobalt chrome, and smart alloy. and this materials can be improvement the surface by coating the titanium 6 aluminum 4 vanadium can be improvement the surface by hydroxyapatite and can be improvement by hydroxyapatite with titanium oxide and can be improvement with hydroxyapatite with ZrO2 zirconium oxide. This coated
Yeah.
materials
Professor,
to
Professor,
prove-
please share your
Yes.
screen, Professor. Please
Okay,
present
okay.
your. Okay.
Yes. Okay. The composition of hang and ringer solutions. The simulated body fluid in tribo-corrosion applications and tribo-corrosion research can be used hang solutions or ringer solution as simulated of body fluid. Hang composition in gram per liter, NaCl, sodium chloride, KCl, CaCl2, etc. This pH for hang solution equals 690, but the pH for ringer solution 6.4. Sodium chloride 8 in hang solutions, but in ringer solution 8.69. In KCl in hang solution 0.4. In ringer solution 0.30. CaCl2 not contained in hang solutions, but in ringer solution 0.48. The comparison between hang solutions and ringer solutions. Can be seen that in research, maybe research used hang solutions. Another research is used ringer solution as simulated body fluid. This
Professor, PPT,
of
PPT,
yes,
PPT.
yes.
PPT, you please share the PPT, Professor. Share screen and you can
Okay,
put the
okay.
PPT.
Yes. Okay. Just a minute, please.
Yes, sir. Yes, sir.
Prof, maybe the problem for this video and
It's okay, sir. Please continue.
okay.
Please continue.
Okay, yes. The solution for this composition of different artificial saliva and this composition of saliva may be saliva 1, saliva 2, and saliva 3. This standard for saliva or artificial saliva for research. Saliva 1 and saliva 2 and saliva 3 contained the sodium chloride, magnesium chloride, calcium chloride, okay, and another component of materials. The tribo-corrosion system. Tribo-corrosion system for research, contact zone, and tribology, evaluation of friction coefficient, and determine the current density or potential, corrosion potential and corrosion current, counter electrode with reference electrode and with working electrode, as well as bin on disk. May be used duplex stainless steel as bin and duplex stainless steel 2205 as bin, and duplex stainless steel as disc 2205, or another material, maybe titanium 6 aluminum for vanadium with 316L stainless steel in bone fixation or in hip implant or artificial joints, and may be used polymer materials, maybe polytetrafluoroethylene or polymethyl methacrylate as bin with ball materials, another polymer materials, or cobalt chrome alloy with 316L. Bin on this is the same material maybe, or different materials. In my research, used titanium 6 aluminum for vanadium as bin with titanium 6 aluminum for vanadium as disc, and duplex stainless steel 2205 has been with a disc of duplex stainless steel 2205. Okay. The setup of measurement of wear and electrochemical parameter, open circuit potentials by potential stat, reference electrode, counter electrode, and working electrode in potentiostat device, and tribocorrosion cells contained Hank solutions. Hank solution as aggressive corrosion environment with the electrochemical actions. The schematic tribocorrosion test, working electrode, reference electrode, and counter electrode in a tribocorrosion cell. The tribocorrosion cells located in my laboratory in University of Kufa in fritting corrosion with computer, and the result of corrosion current and potential of corrosion, as well as can be calculated wear rate in fritting corrosion. The fritting current density for a single step of 2040 micron grit at 0.5 Newton during fritting test. Maybe different roughness, 100 micron, 100 micron, 2040 micron, 600 micron, 800 micron, to simulate to human body. The roughness is not fine, maybe rough to approach to fine, not fine. This fritting current density can be determined when the passive film break of passive film, and can be seen that passivation and depassivation, as well as repassivation. Passivation can be occur at the surface, Cr2O3 at the duplex stainless steel surface, or titanium oxide at the surface of titanium. But when the fritting corrosion and tribo corrosion system led to aggressive led to breaking of passive film, led to debassifications. But in more time, rebassifications, bassifation, debassifation, and rebassifications. In the displacement zone, in a fritting zone, in a fritting area, can be seen that bassifation, debassifation, and rebassifications. The investigation of surface by scanning electron microscopy, the sliding directions at the surface, in morphology of surface, in topography of surface, and can be seen that scratch and the grooves at the surface due to fritting corrosion in a fritting area, or in tribo corrosion area, and can be seen that the debris at the surface and can be investigate the phenomena of bassifation, debassifation, rebassifation by checking by using EDS, energy dispersive spectrometry, collected with the scanning electron microscopy. The scanning electron microscopy micrograph with EDS for investigation the chemical elemental distribution, elemental change at the surface before and after fritting corrosion. Ion release may be occur due to tribo corrosion test. These conclusions for this lecture: corrosion is an important problem in many industries, so it's necessary to know how one discover this problem before the failure can occur. الصورة غير واضحة، ما جيت قراءتهم نهائيا نظهر الصورة. يعني الصور هاي. Just a minute, please.
Yes, sir. Yes, sir.
Is the image clear for you?
Yes, sir.
Okay.
Yeah.
Okay. Fast review for this image. Okay. This tribo corrosion test at anodic and cathodic potential. This composition of Hang's solution and Ringer solution as a fluid body. This Hang solution and Ringer solution simulated for body fluid. This composition for artificial saliva, saliva 1, saliva 2, saliva 3, contains sodium chloride, magnesium chloride, calcium chloride, etc., sodium fluoride. This tribological system, counter electrode, working electrode, reference electrode, with tribo corrosion in tribo corrosion system. Contact zone can be seen that the contact between bend on disk materials, contact zone, tribology evaluation of friction coefficient and corrosion current or potential change. The setup of measurement of wear and electrochemical parameter open circuit potentials. This T sensors, tribo corrosion cells and potentiostat, reference electrode, counter electrode, and working electrode. This schematic tribo corrosion test, working electrode and reference electrode and counter and auxiliary electrode or counter electrode. The fritting corrosion test in my laboratory in University of Kufa, the potentiostat with system of wear configuration. Fritting current density for a single step of 20, 40, 20, 140 micron grit at 0.5 Newton during fritting test. Maybe 0.5 Newton, 1 Newton, 3 Newton to 8 Newton. And the surface roughness 100 micron grit, 20, 40 micron, and 400 micron, and 600 micron, and 800 micron. Rough approach to fine, not fine, to simulated body, human body. Can be seen that baseline current, and can be seen that fritting current, this recovery current when repacifications. Depacification in a fritting zone. Depacification can be occur in fritting zone. In recovery current, repacifications. The sliding directions can be seen that in scanning through microscopy at the surface morphology, scratch and grooves. This debris can be seen that in at the surface for titanium, 6 aluminum, 4 vanadium alloy. Scanning electron micrograph with EDS, energy dispersive spectrometry, for investigate the chemical elemental change. Can be seen that carbon, oxygen, aluminum, chloride, titanium, titanium K alpha, titanium K beta. This fritting corrosion area of 600 micron grit surface. Conclusions: the corrosion is an important problem in many industries, so it is necessary to know how can discover the problem before and failure can occur. There are some difficulties to discover many types of corrosion because of the appearance of metallic surface may be covered by corrosion or product. Therefore, it is necessary to know some details about surface conditions. Biomaterials may be biopolymer, biometallic materials, bioceramic material, biocomposite material, as well as another classification, bio-nanomaterials and bio-smart materials, biosensor materials, bio-high-tech materials. Tribocorrosion is a dangerous form of corrosion because it leads to reduction in material surface, and then the failure can occur without clear warning. A prediction of tribocorrosion rate needs some requirement to be accurate, and then using some method to reduce it or continuously monitor it. Thank you so much for listening.
Thank you so much, sir. It's a very authoritative lecture and excellent.
I am so sorry. I am so sorry because the net is not good in Iraq for this presentation. I hope the high signal of net can be present in high equality. I am so sorry for bad equality because the net is not good.
No issues, sir. No issue. In fact, you have very wonderfully emphasized. You have stressed upon the tribocorrosion and biotribology aspects. You have shown up the excellent work from your laboratory, experimental methods that you have undertaken in your area of expertise. I'm sure for our participants, your lecture, especially for those working in the area of tribocorrosion and biomaterials, biotribology, this should be a very motivating and inspirational lecture. Thank you so much, sir. And I request the participants, so please come forward with the questions to the professor related to the area of his expertise and experimental techniques. Please. Yeah, participants, you can unmute yourself and maybe you can come up and ask some questions. So, sir, maybe to roll out the floor, the questions, maybe I just wanted to ask one question. So you can maybe you can highlight about the future trends in the biotribology or tribo corrosion aspects, maybe the latest trends as well as the future research aspects, ongoing maybe ongoing trends in the biotribology and tribo corrosion, sir.
Okay. The tribo corrosion research in current and the future for improvement the surface, maybe by plasma spray coating, maybe by ion implantation for biomaterials, the titanium 6 aluminum 4 vanadium and titanium 6 aluminum 7 niobium, as well as duplex stainless steel. In my research, duplex stainless steel, my PhD now work about surface improvement for 2101 duplex stainless steel by ion implantation and plasma spray coating, by nitriding and titanium nitride for improvement the surface, as well as the improvement for the duplex stainless steel, another type for my MSc student about the hydroxyapatite with sulfur nanoparticles, because sulfur nanoparticles anti-organism and antibacterial effect for the surface with the hydroxyapatite, and to develop the tribo corrosion resistance for this duplex stainless steel. Duplex stainless steel, my student 2507, 25 chromium and 7 nickel, to develop the surface by hydroxyapatite with sulfur nanoparticles. And MSc student work about hydroxyapatite with titanium oxide, mixed component, hydroxyapatite with titanium oxide at the surface of duplex stainless steel 2205, 22 chromium, 5 nickel. The aim of the project to improvement the surface and to improvement the tribo corrosion resistance. The research is update research for improvement the biomedical application, maybe in orthodontic wires in saliva, or in bone fixation, or in another application in medical applications, because the medical application contain the aggressive environment. The research, most of research used tribo corrosion in saliva and in artificial saliva and artificial or simulated body fluids, enhanced solution and ringer solution. This research in the update research for future, and maybe opinion about improvement the surface to avoid organism, to avoid bacterial, maybe to avoid coronavirus. In the future and this time can be improvement the surface to coronavirus. The stainless steel can be subjected to coronavirus, and the time to stabilization of coronavirus more time by the coating with nanosilver or cold or nano cold to improvement to decrease the sitting time at the surface of maybe any materials. And zinc oxide with silver nanoparticles at the surface to stabilization to decrease the stabilization of coronavirus or COVID-19. Okay.
Thank you, sir. It is indeed excellent.
Are you the answer is understand and very clear for you?
Yeah. In fact, your orthodontic wires that work is really interesting, and I could see that. Yeah. And so yes, I mean this hydroxyapatite coatings on the biomaterials. So in fact, we are also interested to see how the tribological performance of these materials will be. So it's indeed a great to have your sharing knowledge on these areas of your expertise to all our participants. So thank you, sir. So,
Sir,
I
good
hope.
afternoon, sir.
Okay.
I think, sir, we have a question.
Yes.
Yes,
Yeah,
sir.
good
Yes, sir.
afternoon,
Yes,
sir.
ma'am. Yes, ma'am.
I'm
Yes.
Jayalakshmi from IIT Madras. So,
Welcome.
what about the surface texturing and the ceramic coating on the biomaterials?
Yes.
Surface texturing and ceramic coatings.
Okay. Bioceramic materials may be ZrO2, zirconium oxide, with deuterium. The zirconium oxide is not stable, but the zirconium oxide can be stable by addition of yttrium oxide, maybe 3% or 5%. Yttrium oxide with zirconium oxide is good coating as bioceramics. And hydroxyapatite is very useful as bioactive material. The biomaterials can be classified in bioinert, bioactive, and biodegradable materials. This hydroxyapatite bioactive materials, but titanium is bioinert materials. This bioceramic materials that are O2 with yttrium oxide, hydroxyapatite
Hello, sir.
Yes, ma'am. I think Prof might have lost. Yeah, he'll be
Okay.
joining us soon.
Okay, sir.
Prof Ali.
I think he lost the network, sir. I think he will come, sir, again.
Hello, sir.
Okay, ma'am. I think Professor might have lost the network.
Okay, sir.
Yeah. Yes. I hope in Iraq net problem. Yes, correctly. Yeah. So we'll wait for a couple of minutes, sir, for the Prof to join.
Okay, Doctor. Okay, Prof.
Yes, sir. Please, welcome.
Yes.
Yeah.
The bioceramic hydroxyapatite with nanosilver, with nanocold, and titanium oxide, and ZrO2 with yttrium oxide, and the combination of ZrO2 with yttrium oxide and with hydroxyapatite. The hydroxyapatite is very useful and very no expensive materials, because can be produced from fish bones and from animal bones. The hydroxyapatite powder can be produced from waste animal bone and waste fish bone. two research for my student Sura produced hydroxyapatite from fish bone and animal bone, and with the research with Hassanian Latif Jaber using the camel bone to produce hydroxyapatite powder. Can be used as bioactive material and can be used also as coating materials.
Okay, sir.
thank
What
you.
about the surface texture, sir?
The
To
surface
improve the
texture,
surface. Yeah.
yes, the surface texture can be investigated by scanning through microscopy and by EDS, as well as can be investigated the faces by XRD. XRD is very important, X-ray diffraction, for checking the change in faces before and after subjected to corrosion, to tribocorrosion. Is very important by using JCBDS card or ICDD card to investigate the faces before and after tribocorrosion test, under or corrosion test only or wear test only, to investigate which phases can be changed.
Okay, thank you.
And can be used AFM, atomic force microscopy. Atomic force microscopy to investigate the texture in nano scale, the roughness, nano roughness, can be seen that by atomic force microscopy in 3 dimensions. Okay?
Yes, sir.
Yeah,
Thank you,
thank
sir.
you.
Thank you, sir.
And any other questions from the audience, please? Well, I think if there are no questions, then we would like to thank Professor Ali for a wonderful
Thank you.
presentation. Thank you. Thank you, sir. Thank you so much.
Thank
Yeah,
you
yes, sir.
so
Please.
much. I hope to another conference or another activities in the SRN.
Thank you, sir.
Okay.
Thank you. Yes, sir. Jitendra, sir. Yes.
I can be leave at this time, okay?
Yes, yes, sir. Yes, sir. Yes.
Okay, okay. Goodbye and good luck.
Good luck. Good luck. Thank you.
Thank you, sir. Thank you very much to all participants. I will
can
send
be
you the
leave at this
send you
time,
the
okay?
day to link from the mail,
Yes,
and
yes, sir.
along with I will also
Okay,
send the
okay.
feedback form.
Goodbye and good luck.
Okay, so please be aware of this. This is the first day. I am not thinking that this will not work. So please be with us.
Thank you, sir.
I will send it today night.
I will send you the
day to link from the mail, and along with I will also send the feedback form.
Goodbye and good luck.
Okay, so please be aware.